Hi, in this video we will see how to run a design manager study where each design is initialized with the results from the previous design. This can be useful to allow each design to converge faster if the parameter being changed causes the solution to only change a little between each design. In this example, we will perform a mesh refinement study where the same case is run successively with a mesh size of 20 mm, 17.5 mm, 13 mm, and 10 mm. As the mesh is refined, the solution and the pressure coefficient of the case become more and more accurate, but only change a little between designs. It can thus be more efficient to initialize a simulation using a finer mesh with the results from a coarser mesh. This would also be beneficial for other parameters, for instance inlet velocity. For instance, here is the result of a study where the simulations for each design was initialized with zero velocity and pressure fields. We can see that as the mesh's base size becomes finer, the simulations take longer and longer to converge, and in the 10 mm case, the residuals are still not strictly converged by the end of 1500 iterations. We will now modify the sim file to use initial conditions specified in a file table, and we will modify the design manager study to use macros that will import this table before the simulation starts and will save the final results in it. This is the sim file that was used in the design study. You can see that the pressure and velocity are initialized to 0, and the specific dissipation rate and the turbulent kinetic energy are initialized with the default constant. We will use these conditions to create a file table and use this file to initialize the first design of the design manager study. Let's initialize the solution so that it contains the default values. Then we will create an internal table to sample these fields. The table needs to contain the velocity fields, the pressure, the specific dissipation rate, and the turbulent kinetic energy, which are all used to initialize the solution. We want to sample them on the whole region. Finally, we will export the table to the disk. Now let's import the table that was just saved and use it to specify the initial conditions of the simulation. Let's now clear and save the sim file so that it's ready to be run by the design manager. When a design will be run, there are now two additional actions that must be performed. One is to read the file table to load the latest data available, and two is to save the solution of a simulation to this file table. We will create two Java macros to do this. First, we record a Java macro to read the file table into the simulation. Then, we create a macro to export the results to the file. And now, let's create a design manager project based on this sim file. We want to create a design study where the input parameter is the mesh's base size as before, and as before we want to use a discrete set of values of 20 mm, 17.5 mm, 15 mm, 13 mm, 10 mm. In this example, we only want to look at the pressure coefficient and save the pressure coefficient plot and the residual plot. In the run settings, we can use as many cores as are available, but we can run only one design at a time since each design depends on the previous design for its initial conditions. And now, let's use the two Java macros that we have created earlier. We want the Java macro that reads the initial conditions to be executed before meshing, and the Java macro that saves the initial conditions to be executed after running. Now the design study is ready to be run. Now when the first design starts running, it will read the initial conditions from the file table thanks to the first macro, and when it's finished running, it will save its solution back into the same file. When the second design starts, it will read this file and use it as initial conditions, run and save its results at the end of the simulation back into the same file, and the same process will happen several times until all the designs are run. Let's compare how the two design studies behave. Results from the original study are shown in the top row, and the bottom row shows the design study using initial conditions from the previous design. We can see that the first design has a similar convergence behavior in both studies. However, subsequent designs converge faster in the second study. In the last design, convergence is not exactly achieved and the value of the pressure coefficient is slightly below its final value by the time the simulation stops at 1500 iterations. On the other hand, the study that uses initial condition converges quickly and does not have this problem. This also means that if the simulation uses a stopping criteria to stop when the solution has converged, most designs will stop before 1500 iterations, potentially saving a lot of computing time.